Okay, welcome to day one of PreCalculus online. I'm going to do 2 lessons tonight just to kind of get them done for this week, but I kind of need you guys to keep up. We got basically 10 more lessons to cover, maybe less, okay, for the rest of the quarter. A lot of work to do, so we're going to try to get chapter 5 done this week. I don't know how I'm going to quiz or test on it yet. I'll figure that out. I'll talk with the other department what Mancuso is doing and see how they're giving tests. I may have a way to do a test online, maybe on Google Classroom, but don't know. We'll see. So, all right. Anywho, law of sines. So we're going to be looking at the law of sines and solving triangles. It's basically when dealing with law of sines, we are going to be doing finding missing angles and sides of non-right angles. If it was right angles, we wouldn't even need any of this. So these are non-right triangles. Okay, so an example of this. So here we have sine A. Oh, I'm going to turn this on. Sorry, my little writing pad I forgot to turn on. So, all right, there it is. So we're going to have a triangle here. Okay, so not a right triangle. We have A, B, and C. And opposite of side A will be, opposite of angle A is A, opposite of angle C is little c, and opposite of angle B is B. All right, so we're going to prove the law of sines real quick. We're going to show why this is true, because again, if you know, just don't take for granted something is true. So we're going to prove this is true by drawing an altitude, and for those who remember geometry, an altitude is the perpendicular distance from the vertex to the opposite side, and we're going to call this h for height. Okay, so looking at triangle, let's say this is x here, BAX. So we have triangle BAX. If I wanted to solve for h, okay, I want to solve for h, I'm going to use sine of b, all right, and sine of b is equal to the opposite h over c. So since sine of b is equal to opposite over hypotenuse, solving for h means I would multiply by c to get c times sine of angle b is equal to h. And we can do the same thing for triangle CAX. Triangle CAX. Let's see here. We have sine of C is equal to h over b. So again, multiply by b. Cancel. I forgot to cancel that out. So h, or b sine of c is equal to h. Well, since these are both equal to each h, we can say that they're equal to each other. So c sine of b is equal to b sine of c. And then from here, we can just divide by c and b. So that cancels and that cancels. And we're left with sine of b over b equals sine of c over c. So, increase this volume real quick. Make sure everybody can hear me. So, yeah, there we go. We have we basically proved the theorem. And we can do the same thing with finding angle A and side A if we drew another altitude. But I'm not going to, because it's going to be the same process. No point repeating the process at this point. So that's the law of sines. Okay, and we can use this to find any missing side. Now, what we absolutely have to have, is an angle and its opposite side. If we do not have an angle and its opposite side, okay, then either they're going to give us two angles, so we can use the fact that all triangles add up to 180 degrees to find the third angle, or we can't use law of sines. So, like, for example, if they gave us a triangle, and again, A, B, and C this time, where A is 30 degrees, B is 50 degrees, and they gave us C is 12, all right? So I don't have B and I don't have A. I have to have at least one angle and opposite side to find the rest. So if I have two angles, again, I can use the fact that everything adds up to 180. So these add up to 80, which means this is 100 degrees. Now I have an angle measure and the opposite side. So I can say sine of 100, because that's C, over 12, because that's the side C, is equal to sine of 50 over B, and that is equal to sine of, 30 over A. So I can find the missing sides this way. Now, if I'm not given that, if I'm given in the same triangle, I'm given, let's say, 30 degrees here, and that's not even 30, so that'll bother me. I'm getting 30 degrees here, but let's say it's 56 degrees, random number. And they gave this is 8 and this is 6. Okay, I cannot do anything with this yet. Okay, I can't do anything with this yet. There is something I can do in the next section called law of cosine. So if I'm given two sides in the angle between, okay, so I'm given side, angle, side in this case, so side, angle, side, then I have to use law of cosines. But if we're given, like over here, angle, side, angle, or angle, angle, side, okay, then I can use law of cosine, or law of sines, okay. So yeah, not an issue. All right, we're gonna move on. Oh, I can't do that in here, can I? All right, let's do that. So here we have a triangle that is, again, ABC, where I'm going to draw any triangle I want. Okay. So again, if we have two angles, that's honestly the best situation. Anytime we have two angles, it's the easiest. A, B, and C, where A is 38 degrees. It doesn't have to be to scale, because I'm never going to draw it to scale. 46 degrees. Again, I can use the fact that C has to equal 180 minus the sum of 38 and 46. So C is equal to 180 minus 84, which is 96 degrees. So 96 degrees. And I'm given side A over here. The side that's opposite of angle A is side A, so this is 9. This is B because it's opposite angle B, and this is C because it's opposite angle C. So now I can just use law of sine. Since I have angle A and side A, I know sine of 38 over 9 is equal to sine of angle B here, 46 over B, which is, again, I can also do sine of 38 degrees over 9 is equal to sine of 96 degrees over C. All right. So what I'm going to do here, based on both these, is cross multiply. So that's B times sine of 38 degrees is equal to 9 times sine of 46 degrees. And all that's left is divide by sine of 38. Sine of 38. So we know that side B is equal to 9 times sine of 46 degrees over sine of 38 degrees. Same thing over here, cross multiply. We get C times 38. C times sine of 38 is equal to 9 times sine of 96 degrees. And again, divide by sine of 38. And we know that C is equal to 9 times sine of 96 degrees all over sine of 38 degrees. So when you do this, one, make sure your calculator is in degrees and not radians. And let's see what I'm going to get. That there. So plug this in, fraction button. 9 sine of 46 over sine of 38. And that gives me 10.516. Okay, I don't know what they want us to go to. So let's go to 3 decimal places. So again, technically it's approximately because I'm going to be rounding here. 10.516. And the other one, sine of 96 degrees, gives me 14.538. So again, it's approximately 14.538. All right, and that's how we use law of sines. Now again, because I have 2 angles, all right, I can easily find the third. If I only have 1 angle, then that leads us in kind of a bit of a situation. Okay, we have what's called an ambiguous case because we don't know if the angle we do find is acute or obtuse. We don't know if there's an acute triangle or an obtuse triangle, so we have to solve for both. All right, and I'll show you what I mean on the next slide. So yeah, we're good. All right. So here we have the ambiguous case. Okay, and they kind of did a lot of the work for us right here. So here, what we don't know is, given this information, okay, we have a triangle. Could be an acute triangle, or it could be an obtuse triangle. Don't know, okay? So A, B, C, and A, B, C. We know that A is 30 degrees. Again, this is a terrible triangle, but that's fine. This is a little better. And side A is 7, and side B is 6. Now, some of you can already tell that this case, this right here, and do this in blue, this right here doesn't make sense. Okay, and I'll give you a second just to kind of think to yourself while I sip some tea. Why does that not make sense? Why can that not occur? Well, if you remember a little bit of geometry, the rule about triangles is that the biggest side is always going to be opposite the bigger angle. Okay, which means that angle A, being 30 degrees, has to be bigger than angle B because it's opposite the bigger side. There's no way angle B can be obtuse. Okay, and just to prove it, we're going to do the acute triangle first. All right, so we're going to say, and it's all set up right here, sine of 30 over 7 equals sine of B over 6. If you really just multiply both sides by 6, all right, we get 6 sine of 30 over 7. To get B out of here, we have to do the arc sine of both sides. Okay, so that's where they get the arc sine of 6 sine 30 over 7. If you just put all that in a calculator, you get approximately, again, it's going to be a rounding, so approximately 25.4. Now, that's for the acute angle. This is for the acute angle. For the obtuse angle, we just do 180 minus that. Anytime we want to find the obtuse or the possible obtuse angle, we do 180 minus the acute answer we got in our calculator. So 180 minus that is 154.6. Now, that doesn't make sense because everything in a triangle has to add up to what? Every angle in a triangle has to add up to 180, this adds up to 184. So again, there's no way that this will work. So before we even get started, really, if my angle I'm finding is opposite the smaller side, it's going to be smaller. That's just how that works. So we know this is actually 25.4. It can't be anything else. Now, you will come across examples where it could be both, and you have to put both answers. So it could be both. It could be either acute or it could be obtuse, and you just have to solve them separately, and that's fine. You'll just have to do two answers. That only occurs, again, this only occurs when we have this right here. Again, I don't know if you remember triangle congruence. One thing you can't prove triangle congruence is this side angle. I won't write it backwards because this is a video and I don't want your parents, I don't want you taking this to your parents because I got some minors in the class. And you all know who you are. So side angle, we can't prove triangle congruence. This is the incidence. So we have side, and an angle. So anytime we only have one angle, okay, and two sides, I'm going to have a possible ambiguous case to where I'm going to have two possible answers, either acute or obtuse. Again, sometimes it won't be obtuse. Usually it's going to always have an acute side, and I haven't seen one to where it's only obtuse. That wouldn't make much sense, to be honest. So, yeah, it's possible, just not very likely. Anywho, let's see here. Once we know that this is 25.4, we can use, the fact that everything adds up to 180 to subtract this and get this angle to be 124.6, and then do the law of sines again. So to find C. All right. So there we go. And again, that law of sines is, I'll do it over here. Since we have sine A, so sine of 30 degrees over 7 equals sine of 124.6 over C. Cross multiply. Anytime you have your variable in the denominator, just cross multiply. So C sine of 30. And you're going to do this enough to where you can skip this step, because anytime this happens, you're going to flip the fraction and then multiply by this. That's another way to do it. It's just a pattern that comes up, and if you identify that pattern and use it, it's fine. So we have what, C sine of 7 sine of 124.6. So lastly, divide by sine of 30. That's what we have right here. You get 11.5. So 11.5 approximately. All right, now let's look at one that actually does have both cases, because we gotta have one that does have both cases. Okay, so here is not nice for us, at least, is they drew out the triangle for us. So we are given, I'm going to draw on the screen. In B is 12, C is 8. We have angle C, so we're going to be using, this is C and C, or to find angle B first, because I want to find angle B first, because I have side B. Okay, I can't do anything with A, because I have to have at least one of those, and I need to find B so I can find angle A. So doing the setup, again, you could cross multiply, but if this is up top, I want to get that by itself. So I'm going to multiply by, oops, I scrolled when I shouldn't have. All right. So multiply by 12. All right, to cancel that out. And then you're going to do the arc sine on both sides. Now, the reason why they changed this to 3 and 2 is 12 and 8 reduce, because you can divide them both by 4. All right, so you get 3 and 2. You don't have to. I can tell you that's kind of a waste of time to do that, because if you just put 12 and 8 and you write it, and that's just terrible. I'm going to erase that. So I'll just write off the side. So if you write this as arc sine of 12 times sine of 25 degrees over 8, you're going to get the same answer, approximately 39. Doesn't say what to round to, so I hate how they round to whole numbers in this case, and Decimal numbers in the other case, but maybe it is just a whole number. Let me see. So arcsine okay, of fraction button 12 times sine of 25 over 8. Yeah, 39.3. So I would have put 39.3, but that's just me. So this is, given that this is 39.3, I can use the fact that everything adds up to 180 degrees. So 180 minus the sum of 25, and I'm just going to do 39 because that's what they're going to do the rest of it with. So just ignore me. Okay, 39. Add those together, we get 64. So 180 minus 64 is 116. And then we can use sine of 116 over a equals, I'm going to use c again, sine of 25 over 8. Okay, so since this is a, cross multiply, a sine of 25 equals 8 sine of 116, and then divide by sine of 25. So this is going to be your value for a, and that is going to be 8 sine of 116 sine 25, 17.01. Which again, it's the biggest angle, so it should be opposite the biggest side. Again, probably just 17 is fine, the way they're going with things. So this is if b is acute. That's if b is acute. Okay. Well, what if b is obtuse? All right. What if b is obtuse? Right. So here we're getting the same situation, but this time b is obtuse. Now we're going to use the fact that we found b already. B was 39. So to find the obtuse angle, so this is angle B, we'll say acute. Angle B is 39. Obtuse angle B, in that case, would be 180 minus 39. This is, again, is how you always find the obtuse angle. And that will be 1 something. 141. This is 141 degrees. And then we can find angle A by saying, well, 180 minus 141 minus 25. Well, minus the sum of these two. So 180 minus 176, that gives you about, or 166, that gives you about 14 degrees here for angle A. So now we have enough information to find side A. So we're going to say, I'm just over here, sine of 14 degrees over A equals, and I'm going to use C again, sine of 25 over 8, cross multiply, A sine of 25 equals 8 sine of 14, and divide by sine of 25. So putting this in your calculator, .579, it's about 4.6. I don't know what they're running around to in this case. So 4.6. Okay. So there we go. In this case, it could be either one, and you would list both as your answer. And I think they put the final answer down here, so yeah. So you have to list both, and I scrolled real big on that. I don't know why I'm doing this at this point. So you have to list both. One triangle is this. This is if B is acute. Okay. Another triangle is that, and that's if B is obtuse. You list both. Both are your answer. Back up. What are you doing? Now, word problems, because we love word problems, right? Now this one I actually kind of think is fun, so yeah, bear with me. So we want to find what? The slopes in the road. The road slopes 15 degrees, so this is the slope of the road, 15 degrees. That's really a big, I'm guessing this right here is 15 degrees, which is a really big 15 degrees. It should be something a little bit flatter than that. A vertical telephone pole stands beside the road. Okay. The pole casts a 15-foot shadow. Man, this is hard to see what's going on here. This is a terrible drawing. The shadow downhill along the road. Find the height of the pole. Okay. Huh. So I'm guessing this is really poorly drawn. Again, trying to do a two-dimensional shape, a three-dimensional shape on a two-dimensional plane is really difficult. So let's just go the fact that this right here is 15. Okay, so this right here is 15. That's what's saying this is the shadow, the 15-foot shadow. We want to know how tall it is, and this is the height of the pole. All right, we're given that the angle elevation, which is also right here, 65, 65. For those again, remember geometry, these are parallel lines. Because this is a road is going to make parallel lines. It should anyway. We're just going to assume they're parallel. And again, that's a safe assumption for these word problems. Which means that this angle right here is 65 minus 15. So this is 50 degrees. Okay. And if this is 90, and again, this is vertical angles are congruent, 65. And this angle here is 180. Well, technically 90 minus 65 because these two would be complementary angles. So 90 minus 65, so that would be 25. So what's left for angle B, and do we even need angle B? We don't even need angle B here. Doesn't matter because we're just trying to find x. So sine of 50 is opposite x and is equal to sine of 25, which is opposite 15. Okay, so cross multiply. X sine of 25 is equal to 15 sine of 50. Divide by sine of 25. We're going to put that in our calculator, and I still make weird fives, even on this thing. So we're going to put this in a calculator. So fraction, clear fraction. That is 15 sine of 50 over sine of 25. And 27.189. I don't know what they want us to go to, but x is equal to 27.189. That's what you get if you plug this in your calculator. I think that's it for the lesson. I'm going to go to the book and do some practice problems, but for the most part, it's going to be very similar to what we just did, so I may just do a few practice problems. Yeah, that'll be it. Yeah, we're good. All right. So let me go ahead and go to the book. You'll see a second video posted. Do not do the like and subscribe. I don't really care, and honestly, it's a waste of time to subscribe because I'm going to post links to these videos in Google Classroom. You don't want to subscribe to my channel because I have to make this for all 5 different classes, and you would get notifications. Actually, technically 6 classes. Well, 8 classes, technically, because this is the fun part. I also have to do this for Lindenwood. So you do not want to get a bunch of videos about foundation math, calculus, statistics, actually 3 different statistics courses. So yeah, you don't want all that. You don't want all that at all. So yeah, don't worry about like and subscribing because I don't care. and you don't want to get messages about videos you don't want to see, I'm going to post everything in Google Classroom, all the links there. Just keep up with Google Classroom. That's all you need to do. All right, that's the end.